Next we got time series analysis. Now it's a form of regression analysis where time, that's the independent variable. So you got time on the x-axis. You got an example on the book. So you got an example for a retailer, Fun Mart, where you have the sales for 16 quarters of that retailer, quarter 1 through quarter 16, and I've put all the sales dollar numbers right from your book. Now, as I told you, in a time series analysis, on the x-axis, the independent variable, you're going to have time. So you're going to have all the quarters on the x-axis. So you're going to have quarter 1 through quarter 16 right here on the x-axis. On the y-axis here, for this example, the dependent variable is sales. So on the y-axis, you're going to have the sales dollar numbers. So let's say quarter 1, the sales for the retailer is $120. So let's say if this is $120, this is the point for quarter 1 sales. Quarter 2, it's 136. Quarter 3, 134. Quarter 4, it's 145. Quarter 5, 128. So you're going to have a lot of points on this chart. So quarter 14, 166 somewhere here. Quarter 15, 160. Quarter 16, 180. Now with all the points in this time series analysis, you could actually put in or draw in a trend line. And let's try to do that. So if I try to draw in a trend line, it's going to be something like this. So I've done this trend line for quarter 1 through quarter 16, and in this example, it's an upward sloping trend line. Now we could use this trend line that we get in a time series analysis to predict future values of the dependent variable, in this case sales. So let us say we want to predict the sales for quarter 17 or quarter 18. We could look at building up this trend line beyond. So quarter 16. So you could have build this up for quarter 17 and quarter 18 and predict future values. So when you look at long-term trends, generally they are the result of factors like change in population, let's say technology, or change in consumer preferences. Now, there could be other factors that may be seen in a time series analysis, like let's say cyclical variations, which are based on business cycle changes. That's the overall economic situation. In a time series analysis, you could also see seasonal variations, which are based on seasonal changes in activities and preferences. Sometimes you could also have irregular variations, which are based on irregular factors like disasters, which are unpredictable. Time series analysis, and we know that in these analysis, time is the independent variable, as you have on the graph here. So you got all the quarters on the x-axis. So right there, x, which is the independent variable. For sales, right, y, because that's the dependent variable here. Now, on doing the time series analysis on this graph, we could draw a trend line which is sloping upwards. So looking at this analysis, we could say that there is an upward sloping trend. Now, time series data, it could have a lot of random fluctuations, and patterns may be difficult to detect. So here you could use smoothing. Now, smoothing, that's an analytical method which smooths out the random fluctuations on the time series. So let us say on this data, if you're asked to calculate or forecast sales for quarter 17, you could use a few smoothing methods. So let's talk about the first one, moving average method. Let's say to forecast the sales for quarter 17, we want to use the moving average for the previous 3 quarters. So in this case, we're going to use numbers from quarter 16, quarter 15 and quarter 14, all these 3 numbers. So quarter 16 is 180, quarter 15 is 160, quarter 14 166. So if we take a simple average, again as I told you, moving average, if we take a simple average, that calculates to 168.67, and that's the forecast for quarter 17. So guys, as we move on to quarter 18, then we're going to use the actual numbers from quarter 17, 16 and 15. So it's a moving average. So as the quarter move on, you take the simple average, let's say in this example, for the last 3 quarters. Okay, you got other smoothing methods. You could use weighted moving average. So here we had moving average. Now let me write weighted moving average. So now in case of a moving average smoothing method, we gave equal weights to each of the last 3 quarters. So it was basically, you could say 1/3, 1/3 and 1/3, or 33%, 33% and 33%. Equal weighted. We took a simple average. Now let's say we want to take a weighted average, where we say that the more recent quarter should have a higher weightage. So when we are predicting or forecasting sales for quarter 17, we could say the maximum weightage should be given to quarter 16. Let's say 50% weightage for quarter 16. For quarter 15, let's say you want to give a 30% weightage. Quarter 14, that's some time back, so we'll give them less weightage, let's say 20% here. So instead of giving all of them equal weightages, a simple average as you had in moving average, now you're doing weighted average. So when you do this, it'll be basically 20% into $166 plus 30% into $160. So let me put it in a line. So 20% into 166, you're going to have 30% into 160 and 50% into 180. And if you do a sum of these, you're going to get 171.2. So that's the forecast for quarter 17. Similarly, when you, let's say you've crossed quarter 17, you're looking at the forecast for quarter 18. Then you're going to look at numbers for quarter 17, 16 and 15. And then you would give a 50% weightage to quarter 17 numbers, a 30% weightage to quarter 16 numbers and a 20% weightage to quarter 15 numbers. So as you can understand, it's still moving average. So guys, an important point here, it's a moving average. But the second one, what we did here is a weighted moving average. We are looking at a couple of smoothing methods. So looking at the example, we got a table which reflects FundMart's sales for quarters 14, 15 and 16, which need to be used to project the sales for quarter 17. So using highlight moving average smoothing method, we're going to take a simple average of $166 plus 160 plus 80. So sum total divided by 3. And that gives us 168.67, the projection of sales for quarter 17. Now, if we use the weighted average method for smoothing, we need to apply weights. So underline weighted on the table there. And look at this, you got a 20% weight for quarter 14, 30% weightage for quarter 15 and 50% weightage for quarter 16. Draw a bracket around all those weights and write total needs to be 1. So the total needs to be 100%. So in this example, you got 20% for 14, 30% for quarter 15 and 50% for quarter 16. Looking at the calculations, highlight the weighted moving average is 20% into $166, the sales for quarter 14. 30% into $160, that's the sale for quarter 15. And 50% into $180, sales for quarter 16. And that gives us the projection for quarter 17, which is $171.2. Now let's talk about exponential smoothing, where the focus is on the most recent data. Let me put it here. Now, for exponential smoothing, you got a formula which is there on your book. So it says the forecast for the t plus 1 for the next period. For that, we're going to use A. So A is a smoothing constant. I'm going to talk about that. Multiplied by the last period's actual. For the period T, what's the actual? Plus 1 minus A. So if you look at it, A is between 0 and 1. So this is 1 minus A into the forecast that you had for the period T. Naturally, this forecast for period T would have been before period T started. So this is a basic exponential smoothing model. It's complicated. Let me talk about it again. So basically, what we're trying to look at is, let us say we are looking at forecasting sales for quarter 17. So that's exactly what we're looking at. So what's the forecast for quarter 17? Now, to calculate that under exponential smoothing, what we are looking at is what was the actual number, the actual sales for quarter 16. So Y is actual for quarter 16. So if you look at, if quarter 16 is T, quarter 17 is T plus 1. So you're looking at this T and T plus 1. We are also looking at what was the forecast for quarter 16. Now, when would you develop the quarter 16 forecast? Let's say before quarter 16 started, end of quarter 15. So at the end of quarter 15, before quarter 16 started, you would have a forecast for quarter 16. So that's the number that we're going to use for these calculations. So the F here is the forecast for quarter 16. So this is a basic exponential smoothing model. We're just looking at quarter 16. So once again, we are looking at the actual for quarter 16 and we're looking at the forecast for quarter 16 that you would have developed earlier. Now, let me use a little bit of numbers that you have here. So let us say that the forecast for quarter 16 before quarter 16 started was $175. So okay, once again, look at this. Quarter 16 actual sales is 180, but the forecast for quarter 16 was, let us say, forecast for quarter 16 was, let's say, $175. Now the question is, what's the forecast for quarter 17? And that's what exactly we are calculating. And let's assume that the smoothing constant A is 0.2. So let me do the calculations here. So if A is 0.2, what's 1 minus A? Simple math, 0.8. So look at this, 0.2 plus 0.8, that's 1. Now 0.2 is going to be multiplied by the actual for quarter 16, which is $180. And you're going to look at 1 minus A, that's 0.8, and that's going to be multiplied by 175, the forecast for quarter 16. So as you can understand, we're looking at the smoothing constant into the actual and 1 minus smoothing constant into the forecast for the previous quarter. So if you solve it out, you would get the answer of 176. So if you look at it, the smoothing constant in this case is 0.2. So that means there is a little weightage for the actual for quarter 16, and there is a lot more weightage, 0.8, for the forecast that we had for quarter 16. So, and that is why the forecast for quarter 17, that's pretty much close to the forecast that we had for quarter 16. So quarter 16 we had 175 forecast, though the actual was 180. Now the forecast for quarter 17 is highly weighted for the forecast that we had for the previous quarter. So this 176 pretty close to 175. Let me change numbers. I mean, if you change numbers, you'll get a new calculation. Let's assume the smoothing constant, instead of 0.2, let's assume it's 0.7. So let's put numbers here. So this is if A is 0.2. What happens if A is 0.7? Trying to change numbers here. So in that case, it will be 0.7 multiplied by 180, the actual for quarter 16, the actual 180, and plus you would have 1 minus A. So if A is 0.7, what's 1 minus A? 0.3. And that's going to be multiplied by the forecast that you had for quarter 16, $175. So solving this out, so you have 180 into 0.7 gives you 126, and this is 0.3 into 175 gives you 52.5. Total is 178.5. So what we see here is if A is 0.7, we are actually having a higher weightage for the actual number for quarter 16 and a lower weightage for the forecast for quarter 16. So naturally, the number, the calculation, the forecast for quarter 17 is pretty close to the actual that you had for quarter 16, 180. 178.5, pretty close to 180. But then, if you're good with the formula that we have here, so we're looking at the forecast for the T plus 1th period, you're looking at the smoothing constant A multiplied by the actual for quarter 16, that's the T period, and then you're looking at 1 minus A, the smoothing constant, 1 minus A multiplied by the forecast that you have for the Tth period, so in this case quarter 16. Now the problem with exponential smoothing is that I hate formulas, and I'm sure a lot of you do. So I got a mnemonic for you to remember this formula. Yeah. So I want you to ask yourself. So we're looking at the forecast for the T plus 1th period, and I want you to ask yourself. So look at this, A and Y. Ask yourself, isn't part 1 amazing fun? Look at it once again. It's going to fit in. You're going to get to the flow here. So I want all you guys sitting in class here, I want you to ask yourself. So A and Y, ask yourself, isn't part 1 of the CMA exams, part 1 amazing fun? A and F. So once again, I want you guys to ask yourself, isn't part 1 amazing fun? Exponential smoothing. Looking at the basic exponential smoothing model, you got the forecast for the T plus 1th period equals, highlight A and circle Y. So this is right last period's Y or actual. Then on the formula you got plus, highlight 1 minus A, which is multiplied by circle F, and which is right last period's forecast. So the exponential smoothing model, we know that highlight A is the smoothing constant. So A could be between 0 and 1. And I've given you a mnemonic to remember the formula for exponential smoothing. And I've asked you to ask yourself if part 1 isn't amazing 1. So highlight A, circle Y, highlight 1 minus A, and circle F. So use this amazing mnemonic to remember your formula for exponential smoothing. Now let's look at the example where we have a table with the sales for quarter 14, 15 and 16. And here we'll just use the quarter 16 numbers. So where you have sales, write Y. Highlight the formula there. Forecast for quarter 17, and that's equal to, highlight 0.2. So that's the smoothing constant here, multiplied by $180. So that's last period's or quarter 16's actual, plus 0.8. So 1 minus 0.2 is 0.8, which is multiplied by the last period's forecast. That means the forecast for quarter 16, $175. And this calculates to the forecast for quarter 17 to be right there, $176. Below that, right, implications. If A is close to 0, next period's forecast is closer to last period's forecast. As we can see on this example, so draw an arrow and write closer to $175. So the forecast for quarter 17 is closer to the forecast for quarter 16, $175, and a little far away from the actuals of quarter 16, that's $180. However, right, if A is close to 1, next period's forecast would be right closer to last period's actual.